Hello everybody. I'd like to work the two sample problems on page 25 of the distance learning packet. So I'm going to read the problems and then make a list. I'll probably draw a picture and we're going to evaluate what's going on, what type of collision it is, and find the quantity that they're asking us to solve for. A 1 kilogram ball going 1.2 meters per second strikes a second ball at rest, which is 2 kilograms. If the 1 kilogram ball is at rest after the collision, what is the velocity of the 2 kilogram ball? So I'm going to make a list with M1, M2, and the velocities that I'm given. These are the masses and velocities of the two balls to begin with. If we read the problem again, we see that's the case. I'm also going to draw a picture. I put a squiggly line to indicate the collision, because to the right of that will be after the collision. Similarly, I'm going to put a squiggly line in my list, and I'm going to have the two velocities of the balls 1 and 2 after the collision occurs, what we call V1 prime and V2 prime. After the collision, ball 1 is at rest, and we are looking for the velocity of ball 2 after the collision. So the two balls do not stick together. They bounce off each other. This one is at rest to begin with, and this one moving. This one stops, and this one's moving. So it's an elastic collision, and I'm going to write down the elastic equation. As we can see from our list, two of the velocities are 0. The velocity of the second ball to begin with, and then after the collision, the velocity of the first ball is also 0. If this is 0 and this is 0, then the entire term M2 V2 is 0, as is M1 V1 prime, because V1 prime is 0. Rewriting it now with the remaining two terms, we have this, and we're going to solve for V2 prime, because that's what we're looking for. Dividing both sides by M2, we get M1 V1 over M2 equals V2 prime, and we can now substitute in our values. And we see that V2 prime equals 1 over 2, a half of 1.2, which is 0.6 meters per second. I'd like to point out, and hope it makes sense as well, that this velocity is exactly half of what the initial velocity of the lighter ball was, because that ball gave all of its momentum, it stopped, and gave its momentum to an object that was exactly twice its mass. That's going to result in half the velocity, because again, the momentum is conserved.